Okay, so welcome to week 8. This is a relatively shorter week compared to what we've been doing the past few at least certainly. We're going to talk about strings, a little more about strings and only strings. Uh, quick few things that we didn't know before. We'll recall that a string is basically a line of characters in double quotes or single quotes, right? So, topics in the book are basic string operations, string slicing, and then a whole bunch of functions and methods for testing and searching and manipulating the strings themselves. So, let's jump right in. Again, it's kind of a short week. Um, Strings are sequences. And if you remember, we learned about sequences last week. Lists and tuples are also sequences. So just like a list or a tuple, strings are sequences. That means they can be iterated. That means they have special methods. And we'll think about the dot notation, okay? And you can also have access to individual elements of the string. And for that, that means the characters that make it up. So how do you access those individual characters? Well, there's two ways primarily. We can use a for loop, for character in string, and then iterate through the string. Or we can use indexing, just like a list or a tuple. In fact, it's a little more like a list because it uses the square bracket notation. And we'd say something like, character equals my string bracket and give it an index value starting at 0 and going up until the end of it. Okay? So there's lots of tools we have for looking at strings and manipulating them. These are the ones we're going to start with. So let's talk about like a for loop, for example, right? So you go through this iteration. Let's say we have a string called name, and it's the name Juliet. The first character would be a J, obviously. So we might say for character in name, print the character. And it will cycle through that until there's no more characters left in name. So each time you go through, the value of CH would be one individual letter, each one in sequence as part of that name. Not a hard concept, just like a list, only there's no commas involved. It's just the literal string here. So again, every individual character of a string can be indexed in and of itself. So if we have the phrase roses are red, the capital R is index position 0, going all the way through to the end. Notice 5 and 9 are the spaces. They are still part of a string, so they are still indices, and they are still ASCII characters of space. Okay, and we have 13 characters from 0 to 12. And you can basically just say some character is assigned and then pick a position. So for example, roses are red, character equals my string, index position 6 would be the A. Again, this is very similar to lists, which you will be practicing in the lab. The one thing you got to worry about, just like with a list, is if you get toward the end. An indexing error almost always happens when your loop goes past the end of the string. That's when you get the index error, almost always. There's a few exceptions, but pretty much if you're getting an indexing error on a list or a string, your loop is off by one, probably went a little farther than you should have. So what we have then is the len function that tells us the length of the string. Okay? And again, just helpful for not going past the end of your string when you're trying to loop it in your for loop. Although if you use for character in string, then you're in good shape. All right, so that's indexing. Again, just like a list or a tuple, actually more like a list because of the square bracket notation. You can also concatenate two strings together. Now, there's an interesting thing here, okay? Strings are actually immutable. And if you remember that from last week, that means they can't be changed. So you can do this, right? You can say existing string equals itself plus something else, or you can use the augmented assignment plus to say plus equals, okay? And that's fine. And in fact, if you're using the plus equals, remember the thing on the left has to already be existing at that point. But the important thing is here, strings are actually immutable. And once you create them, they can't actually be changed. Well, Professor, you just said this. Yes, I did. Concatenation officially in Python doesn't actually change the existing string, okay? It just treats it like a new string starting over from scratch again. Kind of like if you create a new list with empty brackets and then went from there. So even though it is a sequence, you can't actually just treat it like a list element, okay? They technically are immutable, and that's going to come up in a second here. But again, if we have name equals Carmen, and then we decide to say name equals name plus Brown, it actually just forgets about Carmen originally, and it just goes and creates a new one. It doesn't actually append to a string per se. And the reason why that's so important, which means you can't do this, even though you can access an individual character within a string, and that would be how you do it, string, square bracket, index, you can't actually change a single character within a string because it's immutable. If you do that, you will get an exception error. So again, just like it's just like a list element, except it's immutable. Okay. So characters you can pull out and read and notice, but what you can't do is you can't replace a character within a string. You have to reassign the string, which essentially creates a new one. All right, string slicing. We talked about slicing with lists and tuples as well. Slice basically just takes part of that. A slice of a string is also called a substring. And again, the format for slicing a string is just like that of a list. String, bracket, and a start and an end with colon separating them. And you get, that's your value, right? Your step values. You can also have a step value. You can have start, end, and go up by so many, so you can skip every other character if you wanted to. And you can have a negative index. -1 being the last character of the string, -2, etc., all the way backwards. Just like a list, you can reference and slice individual characters from into a substring. So, again, if the end is not specified, it uses the entire length of a string. If it is specified, obviously it only goes from the start to the end, not inclusive. So slicing, again, just like a list. Told you, we're just going to be burning through some of these. It's all these operators you've seen before. We're just talking about them now within the context of a string. So the in operator, you can look for text inside a string to determine if something, a substring if you will, is contained within another string. So you'd say, string 1 in string 2. Conversely, you would say string 1 not in string 2 to see if it's not contained in there as well. Okay? And it could be string literals, or it could be variables referencing parts of the string. But the same way you do that, and these are functions that would return, these are Boolean tests that would return a Boolean, right? So if you said, is O in Tom, that would come back as true. Okay? In and not in, the same as the lists from last week. String methods. Let's seriously talk about methods again. Remember that the methods in any object take this dot notation. So you will have a variable dot, whatever the method is, and then whatever arguments in parentheses. They're kind of like functions because they have arguments and they use parentheses to call those arguments. But instead of saying some function blah, it's your object, in this case our string, dot whatever method we want. So similar but a little different than functions, okay? Generally, most of the methods for a string are Boolean, which again will return true if the condition exists or false if not. Here is a bunch of the most common ones for strings. So just going right down this list, is L_num returns true. All these are going to return true. These are is something. If there's only letters and digits in there, as opposed to any special characters like a period or a dash or a $sign, that kind of stuff. If it's only alphabetical letters or numbers in there. Is alpha returns true only if it's letters. Okay. All of these, of course, have to be at least one character in length. You wouldn't have a letter if it wasn't. Is digit returns true only if it's numeric digits. Okay, and again, at least one character in length. Is lower, or the bottom one there on this list as well, is upper, returns true if all the letters that are in there are lowercase or conversely uppercase for the bottom one. And is a space. Returns true if the string contains only white space characters. White space characters are new lines, spaces, and tabs, pretty much. So there you are. If there's anything else besides white space, then it would return false. Okay, let's take a look at this and see what we can do with this here. Table 8.1. This is table 8.1 in your book, by the way. with all these methods in here. Okay. Let's do a new file here. I'll bring it right over. And actually, let's just say string 1 equals, let's just say 1200, a number, right? We would use one of these like this. If string 1 dot is digit, okay, and make sure we have our parentheses in there, a colon there, print string 1 comma, let's just say contains only digits. Else we can say print string 1 contains characters other than digits. And we can save this. Oops. And we'll run this. 1200 contains only digits. Pretty simple. If I threw a couple letters in here and saved it and ran it, and now we get contains characters other than digits. So it should not come as any surprise, I would hope. Let's this is another one in your book. It is program 8.5. You could find it in that section of your book. I believe it's section 8.2. So again, this program is very simple. It asks the user to enter a string, and it tells us all the different functions we can do here. Is alnum, is digit, is alpha, is space, is lower, is upper. And it will tell us which ones it actually follows. So let's just run this one and see what we get here. Enter a string. Do not use a password of pass1234. That's the string I'm going to choose to type in here. And it finds absolutely nothing about that string. Interesting. Well, does it contain only alphanumeric things? Nope, it's got a space in there. Does it contain only digits? Definitely not. Is it only letters? Definitely not. Is it only white space? Nope, not that either. Are the letters all in lowercase? No. Okay, this was a bad example. Should we try this again? Help! Now we have something going on here. The string is alphanumeric. Now, just because it doesn't have numbers does not mean that it isn't alphanumeric. It doesn't have anything. It has letters and or numbers and nothing else. So it is alphanumeric. This one does only contain alphabetic characters, and they are all in uppercase. Let's go the other route here. 1, 2, 3. It is alphanumeric, and it contains only digits. Let's do one more test here. Tab. Enter. It contains only white space characters. And let's just try one more, a string with nothing in it. It does not have white space. Technically, the new line is not part of the string we entered. So, that has nothing. All right, so those are the first few. These are all methods. Again, you call them with the dot notation. So my string name dot one of these methods. And these are all true-false methods. There's a few more here. So some test, like the ones we just had, others modify. And I'll use the word modify very loosely, okay? Remember, we said strings are immutable. That means we can't modify them, technically. But there are methods that will return a modified version of that string. It doesn't change the string, it just returns a value of that modified string, and that's very important to understand the difference. We are not changing the string. The method we call, instead of like the previous ones here that returned true or false, these methods are going to return effectively a copy of the string with whatever we're doing to it. So some of these would be turn everything to lowercase, strip all the white space, the leading white space characters. So if there's tabs or any white space characters in the beginning of your string, it'll take it off. Not to be confused with the rstrip carrier. We actually talked about this one last week as well. A few weeks ago, when we were talking about files and file objects. When we read from a file, there is a new line character at the end of that line. And so we used rstrip to take the white space, which one of them is the new line character, off the end of the string. So like left and right, since in at least English with what we're programming in Python, L would be the left, the beginning of the line, R would be the right, the end of the line. We have lstrip and rstrip, we said, yep. We can give it a character for each one of those as well, too. So if you want to take off a specific character, you can pass that character in. Strip will return a copy of the string with all the white space removed, leading or trailing. Okay? Same thing with a character. You can strip a certain character out, and then upper, which is kind of the counterpart to lowercase. Okay? And so because of that, string comparisons are case sensitive. Okay? Uppercase characters are distinguished from lowercase characters, and you can use those methods again to change them if you need to. So if you think about when you log into certain websites, if you ever done it from your phone, for Android users out there at least, it always wants to capitalize that first letter you do. And in some systems, that might be a problem. In other systems, it's not. And so what a lot of programs do behind the scenes as part of validating a username's input is they'll convert everything to lowercase just to take out any ambiguity so you don't have a capital name and a lowercase name being two different usernames. So done with upper or lower as methods. So is, lower string name dot lower to convert them all to lowercase. And again, that doesn't change the string. It just provides a value to test against while keeping the string exactly the same. More methods. Sometimes you need to search. Sometimes you need to find something within a string and not just test whether it's upper or lower or if it's just letters. Sometimes you actually need to find a substring from within one. So we have ends with and its counterpart starts with that return true or false. If a string ends with or starts with whatever you pass it. So if we pass it, capital A, starts with capital A for our method. If our string starts with capital A, then it would return true. Find and pass it a substring. What it does is it returns the first instance of the index value of where our string is. So if we have Mary had a little lamb, and we were trying to find A. There's an A in Mary at position 1, because remember the M is 0. A would be position 1. So we have Mary space had, the sixth character, or sixth position, seventh character would be an A in had, 7, 8, 9, and then a little lamb. So there's 3 A's right there in the beginning. Find A as a method would find the first instance of an A, which would basically, again, position 1. If whatever you type in as a substring for find is not found, then the function returns a -1. Since you can't have anything less than 0 as an index value, -1 is the counter to, not found. It returns an integer value, so you can't have it return a false if it's not found. So -1 becomes the false if the substring is not found in the main string using this find method. And then replace, again, returns a copy. It's a return function, and it returns a copy of the string where every occurrence of whatever you type in for substring is replaced with what you pass in there for a new string. So we can look at some of these. Again, here they are. I'll just leave this up for a little bit here. This is right out of your book. Again, table 8.3. Let me open another one here. I made one for this week. And I'm just going to clear this out a little bit here. All right, so here's my string. It's 7 years ago. What we're going to do with this? Well, we're going to print the string is and print the string out, just so we all see it. We are going to find the word 7 inside the string. So you see here, position equals string.find and the phrase, the substring that we're looking for here. If it is not found, sorry, if it's not -1, meaning if it is found, we're going to say the word 7 was found at index, and then we're going to print that position from here. If it wasn't found, then I'll just say that. Okay? Then afterwards, I'm going to have a little pause here so we can say press any key to continue. And then we're going to actually try to replace a phrase here, okay? Now, let's run this. We'll show you what this looks like. Did I change something? All right. So the string is 7 years ago. Slide this up so we all can see it. The word 7 was found at index position 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's the beginning of it right there. Index position 15 is this S right here. And that's where the word 7 starts. That's where the substring that we looked for, that we were looking for with the find method, was found at index position 15. I'm going to actually cancel out of this. And now we're going to say some gobbledygook that really doesn't exist. We'll save that. And, well, I wrote the word 7, but you get the idea. What I was looking for was not found, which was this. Okay? All right. Now, press any key to continue. What's going to happen when we continue? I've got two inputs here. Word equals input, what word do you want to replace? Replace equals what word do you want to change it to? So I'm going to pick one of the words from here, and we'll replace it with a different word. Now, what I had the program do afterwards then is print out the function returns, and here's our string replace command right here, method, okay, with our two parameters, word and replace, that we got from here. Okay, and then when we're all done, after it prints what the function returns, I'm going to have it print the actual string again, because I want you all to see that the important thing here is that the string is unchanged. Again, these functions, these methods, return a copy of the string with the modification made. So what word do I want to replace? I just recently rewatched Bill and Ted, so I think thinking about Abraham Lincoln from that, I'll say we'll change the word years, because he says 7 minutes ago in that movie. So we do that, and what we'll get is, when I press enter here, is we're going to get the function returns and then our string replace, and then we'll get the string again, the original string, the way it should be. And as you can see, the function returns 7 minutes ago, while the string is still 7 years ago. Because again, this string replace method here only returns a copy of the string and does not change the string's value. And these are important things to consider when you're working with strings. All right, so those are most of the methods we'll be using for strings. Again, none of these are new. We've talked about them from last week. So Lab 7, Lab 8 will both be pretty, Lab 8, Lab 9 will both be pretty repetitive as far as working with lists and strings to some extent. Obviously, we're going to do different things with lists than we will with strings completely, but there's a lot of similar functions that kind of cross over. Okay, and again, they're used with methods using the dot methodology: string dot replace, string dot find, etc. All right, almost done here. Two more things here. The repetition operator, again, no different than what we've seen before with repeating anything else. We can do it with any character. We can do it with any integer. We've concatenated lists together like this. So I mean, there's same thing. It repeats a character in the string over and over again. So let's find something we can use as an example here. Like that one. Close this up. All right. Real simple. For count in range 1 to 10, print a z times the count. So the first time through to be a 1, next time through to be 10. We're going to print a bunch of z's going down, kind of like our star pattern from our lab a few weeks ago. And then we're doing decreasing length. From 8 down to 0, -1. So let's just watch this run. We'll make the window a little bigger. But there's our z's. Okay, just repeats it. No different. This is a string times however many things we're repeating it by. That should not surprise anybody, I hope. And then lastly, splitting a string, which is something we can do, and we're going to do this a lot as we finish out this course here. Basically, when you split a string, you can split it by whatever character you want. By default, it's a space. So if I had a particular Mary had a little lamb or 7 years ago, it would return me all the words in a list. So they give me a bracketed list: 4, score, and, 7, years, ago. That would be the list that I would get returned by using the split. So, new string is actually a list. Okay, so if we were to say new string equals mystring.split, mystring is clearly a string. When we split it, what value that's returned back to this variable here is actually a list. Okay, let's look at one of these. Let's just look at one of these. Let's do split date. Where is it? Here it is. Slide this over. So again, by default, it uses a space. We can also pass split another parameter. In this case, we're saying split it at the slash sign. So this becomes very functional for splitting a date into its month, day, and year. Okay. So if I run this, and you see our date string here is 11/26/2012. If I run this, it basically splits the date off. And if you look, date list equals date string dot split, passing it the slash, print month, day, year, list position 0, list position 1, list position 2. Okay, nothing we haven't learned before with lists. This is just more repetition of concepts we've already used. The good thing is all these methods, or most of these methods at least, are not new to you. You've worked with this kind of notation, with this indexing notation with the square brackets. There's more in the lab for this week. There'll be more for the string lab next week. Okay, and that's pretty much it. The other place split becomes very useful if anybody is working toward a computer science degree where you're going to be working with log files or system administration or any of that. I've written plenty of programs myself where log files are usually split by commas, sometimes by semicolons or colons. Sometimes config files are separated by colons in the Unix world. And you can run a split on each line of a config file or a log file. Read in the log file line, split the string that you get at a colon or a comma, whatever it might be. You can also use this in conjunction with Google Sheets or Excel files that are saved as comma-separated values. And again, real quick ways of pulling information out of database tables or spreadsheet tables and being able to work with them on a very individual field type basis. So that's what we got. That's the summary of everything we've done today. That's all we're doing this week. Really short week this week. String functions, again, iterating with loops. Don't forget your len function. Those are the actual functions. The len is the only function that would work with it, actually. And then all the different methods. And I've only listed a few here. Your book has all of them in the tables. But changing things to changing, but returning a value for turning it to alphabet, seeing if it's alphabetical or numerical or whatever, converting something to lower or uppercase, or taking white space off, and then finding things within a string. See if it starts with or ends with or has somewhere in there a particular thing, or even modifying at least the output from the method to replace part of a string with something else. That's all we got for this week. I hope you enjoy your shortened week. Don't forget, though, there is a test. So take all that as you will, and good luck to you this week. Again, if you have any questions, post it in the Q&A forum or send me an email. Have a great week, everybody.